Good evening, Your Honor, ladies and gentlemen of the jury. My name is Tiffany Erickson, and I am here to present the results of a thin layer chromatography, also known as a TLC analysis, that was conducted as part of our drug analysis lab. I will walk you through the procedures, the data, and the key findings from the experiment that I did. The summary of the procedure, starting off, thin layer chromatography is a technique that is used to separate and identify components of a mixture, what makes up that mixture. And what I did for my lab was I had 6 different drugs. It was Benadryl, aspirin, caffeine, ibuprofen, Tylenol, and Excedrin. In each of those drugs, I took a fourth of the drug and crushed it into a powder. And I had 6 different tubes, and each drug was put into each tube labeled, and methanol was added to the solution to help dissolve the drug. Then a developing chamber was prepared by adding methanol to a beaker. So just a regular beaker, adding methanol to the bottom of it, which like a thin covering of the bottom, and allowed to equilibrate or settle. And then once the drugs were dissolved in the methanol, I took a pencil on the TLC plate and I drew a baseline about a centimeter from the bottom for my starting point for my drugs. So I applied a small drop of each drug onto the plate. There were 3 per TLC plate, and I allowed each spot to dry before reapplying so I could concentrate the sample in that specific spot. So there was enough sample in that spot to work across the TLC plate. So the TLC plates, after the 3 drugs were placed on the first TLC plate, I did Benadryl, then aspirin, and then caffeine on the first TLC plate. And then on the second TLC plate, I did ibuprofen, Tylenol, and Excedrin. And I placed the plates one at a time. So I placed one plate into the beaker and allowed the solution, the solvent, the methanol solvent, to run across or travel up the plate until it was about 1 centimeter from the top of the TLC plate. When it was about 1 centimeter from the top of the TLC plate, I took the TLC plate out, allowed it to air dry, put the second TLC plate in, and repeated this step. Once that was out, allowed that to air dry. And I put a mark at the top when it was about a centimeter from, as soon as I took it out, I put a line in pencil at the top where the solvent ended. So that way, once the solvent dries and evaporates out, I can still see where the solvent ended. So once those 2 were dry, I then used a UV light to visualize the spots for each sample to see where they travel. And that tells me which drug traveled which distance, and using that and the distance the solvent traveled, I can find a value known as an RF value. And that helps me determine differences between different chemicals. So in the first set, like I said, I used Benadryl, aspirin, and caffeine on the first TLC plate, and the solvent traveled 4.8 centimeters for that specific plate, with the Benadryl traveling 2.7 centimeters, the aspirin only traveling 1.8 centimeters, and then the caffeine traveling the furthest at 3.2 centimeters. On the second plate, the solvent traveled a distance of 5 centimeters. The compounds that were on that TLC plate were ibuprofen, then Tylenol, then Excedrin. The ibuprofen traveled about half the distance, 2.5 centimeters. The Tylenol traveled almost as far as at 2.4 centimeters. And the Excedrin, because Excedrin is the name brand. Excedrin is actually composed of aspirin, acetaminophen, and caffeine. So Excedrin, there were 3 markers. There was one at 1.7 centimeters, one at 2.4, and one at 3.1. And so that shows me that that is composed of 3 different chemicals, more than likely the aspirin, the acetaminophen, and the caffeine at the end of it, based on their distances. So the RF values are calculated using a formula. You take the distance the sample traveled and you divide it by the distance the solvent traveled. So for Benadryl, it traveled 2.7 centimeters out of 4.8 centimeters. So when you divide the two, you can calculate the RF values for each drug, which is useful for identifying and comparing the substances. So the RF values for each of them. So the Benadryl, like I said, was 2.7 centimeters, and it traveled 2.7 centimeters out of 4.8, giving it an RF value of Benadryl that I calculated. It ended up having an RF value of 0.46. Okay, and the aspirin, so after Benadryl was aspirin, the aspirin traveled 1.4 centimeters out of 4.8. So that gave it an RF value of 2.9. And the caffeine traveled 2.5 centimeters, 2.5 centimeters out of the 4.8. So that gave it about 0.52 for the RF value. The next 3 on the next TLC plate were ibuprofen, which ended up traveling half the distance. So that one was easiest. 2.5 centimeters divided by 5 gives me 0.5. Then the Tylenol traveled 2 centimeters out of the 5 centimeters, giving it an RF value of 0.4. And the Excedrin ended up with 3 RF values because there were 3 different components to it. So as I had said, Excedrin's made up of acetaminophen, which comes from your Tylenol, your acetaminophen, your caffeine, and your aspirin. So there ended up being 3 spots on there, and each one had its own RF value. So the spot that traveled 2 centimeters ended up with an RF value of 0.4. The one that traveled 2.5 centimeters out of the 5 centimeters ended up with an RF value of 0.5. And then the aspirin, which only traveled, the spot that only traveled 1.5 centimeters out of the 5 centimeters ended up with an RF value of 0.3. Now, the different spots are indicative of aspirin, caffeine, and acetaminophen. However, it doesn't specifically say that's what those values are. But knowing what the components are in Excedrin and the 3 spots, it is safe to say that that's what those values were. So when dealing with TLC, thin layer chromatography, there is a mobile phase and there is a stationary phase. In the TLC experiment, the mobile phase, so that's what's moving, is the methanol. And that methanol is going to move up the TLC plate carrying the drug sample. The stationary phase, which doesn't move, is the silica gel coating the TLC plate. So on the plate, there's a silica gel coating, and that's what the stationary phase is. It doesn't move at all. It's the methanol that's moving up that silica gel. Now, the significance of these components lies in their ability to separate the compounds based on their interactions with each other. So the mobile phase helps the compounds, helps to move the compounds, while the stationary phase allows for the separation in the different areas based on their affinity to it. Now, the reason why, so on one of them we ended up with 3 different spots. The reason why some substances move at different rates, because I ended up with different RF values and different different distances, and that can be indicative of a couple of things, but mostly it's that they're different substances, and different substances are going to move at different rates due to their varying affinities for the stationary phase. and their solubility or their ability to dissolve in the mobile phase. So compounds that interact more strongly with the stationary phase will move slowly because they're interacting more, while those that are more soluble in the mobile phase with that ethanol are going to move more quickly. So it depends on if they are more soluble in that silica gel coating or in this case, the methanol, the solvent that was used. So the purpose of the RF values that I had mentioned previously. So calculating the RF values is quite simple. You just divide, a part over a whole. Now, what is the importance of those RF values is the better question. And the RF value is calculated by dividing those two distances. The distance the drug traveled by the total distance the solvent by the solvent was. More than likely, your drug isn't going to travel the complete distance of the solvent. And in this case, it didn't. So, for example, and actually I listed all of mine, but so for example, if it only travels 1 centimeter, the drug only travels 1 centimeter and solvent travels 2 centimeters, 1 divided by 2, you get 0.5. Now, these RF values are crucial because they help identifying compounds by comparing their migration or their movement patterns to known standards. So we'll have a library list of known standards and we can compare these values to those known values that we already have. So TLC, the thin layer chromatography test that I use, is actually considered a presumptive test. So I know I had mentioned that in Excedrin, there were the 3 different compounds, and I had mentioned the 3 different compounds that are used. However, doing thin layer chromatography doesn't tell me that those 3 spots on that were this, and this. It just tells me there were 3 spots at 3 different locations on the plate, and so there are 3 different RF values. So I could assume, but I don't want to assume because I don't know. What I do know is that I placed a substance that I was under the impression of that I knew was Excedrin, and I did the TLC for that, and I came up with 3 different spots. And knowing some values of those 3 different of different compounds, I could say what those 3 different compounds could possibly be. A presumptive test just means that I'm presuming that I'm not entirely sure. It gives me an idea, it narrows down. So TLC as a presumptive test means that it indicates that there's a presence of a substance based on their separation or their migration patterns, the way they move. But it does not definitely, for sure, this is the definitive identification without further analysis. So then after this, I would go to a confirmatory test to confirm that substance and then what's in that substance to confirm what those 3 spots were for, etc. So the presumptive test actually helps narrow down the possibilities so that it can guide me to additional testing for a confirmation on those substances. So overall, the thin layer chromatography analysis of these different drugs does provide valuable information on the separation and the identification of drug samples, but there are some challenges. And part of that is that it's a presumptive test, which means that there's only so much I can do, but I can't say for certain this is this compound or this is in this compound. So thank you for your attention, and I am ready to provide further details or clarification as needed.